Today we will discuss the behavior of an electrical forced oscillator. In our previous lectures, we have discussed the behavior of mechanical forced oscillator. Now we will discuss behavior of electrical forced oscillator. Electrical forced oscillator. So it is very simple that we know that LC circuit is known as the electrical oscillator and LCR circuit is damped electrical oscillator. L, C and R. It is damped electrical oscillator. When we apply an external voltage to this oscillator, that is external voltage we apply, that is EMF is equal to E naught e raised to power minus iota omega t. So it is periodic voltage which is applied to this circuit to get the forced oscillations. So LCR circuit is damped electrical oscillator. When we apply periodic voltage to this circuit, then overall this is called electrical forced oscillator. So in this case, first of all we have to derive an equation of forced oscillator, then we will solve that equation to find different parameters, that is charge, current and the rate of change of charge with respect to time. So first of all, derivation of equation of motion or equation of voltage. You know that we will derive the equation by using voltage. So voltage across inductor, voltage across capacitor, voltage across resistor. Let this voltage across VL, VC and VR. There are different voltages, that is VL, VC and VR. So voltage across inductor plus voltage across capacitor, voltage across resistor is equal to this applied voltage, that is epsilon naught e power iota omega t. So voltage across inductor in magnitude, it is L di upon dt plus this VC, voltage across capacitor is Q by C plus this IR. You know that voltage across resistance V is equal to IR, and it is voltage applied iota omega t. So this voltage is responsible to produce forced oscillations. So it is extra or external periodic voltage applied to the circuit to get forced oscillations. So we may convert this equation in terms of charge. So L into d square cube upon dt square. You know that current I is equal to dq by dt. So ddt of dq by dt is d square q upon dt square plus q by c plus this I again taken as dq by dt into r. This one is equal to this epsilon naught e power iota omega t. So this is the second order differential equation in Q and T, and overall this equation is called equation of electrical forced oscillator. Now we will solve this equation. So it is same as the mechanical force oscillator. which we have studied in the previous articles, in the previous lectures. So we will discuss its behavior or find its solution. So the solution of this equation of forced electrical oscillator. We will find the solution of this equation. So again, there are two possibilities, two types of solutions are there. First one is transient solution or transient behavior, and second one is steady state behavior. Steady state behavior. So same transient behavior, first one. First is, it is the behavior of the force oscillator when the right hand side of this equation becomes 0, and the equation become L d square q upon dt square plus this R into dq by dt plus q by c is equal to 0. So in case of this transient behavior, there is no external voltage, applied to a circuit. So this behavior is called transient behavior. So this behavior is same as the behavior of damped electrical oscillator. This is the equation. You remember that this type of equation is already we have discussed in the previous article, that is behavior of damped electrical oscillator. So its solution is same as the solution of damped electrical oscillator, and there are three cases, that is hybrid damping, critical damping, and third one is lightly damping. So three type of behaviors can be obtained by using this, by solving this equation, and finally we get the frequency is equal to square root omega naught square minus b square, or omega naught means 1 by LC, because omega naught square is 1 by LC, and b square is R square by 4L square. So this is the omega dash frequency of the damped electrical oscillator. So this type of behavior which we have already studied. So we will not go in detail for solving this behavior. So we will solve steady state behavior of forced electrical oscillator. Now, steady state behavior of forced electrical oscillator. So it is that behavior in which external force is not 0, means external force is also applied to the circuit. So the same equation, that is L d square q upon dt square plus R into dq by dt plus q by c is equal to E naught epsilon naught e power iota omega t. So we may solve this equation by taking the solution of this equation as, let q is equal to q naught e power iota omega t, or you may also consider the equation as I is equal to I naught e power iota omega t. So we will find the solution of this equation either by using q is equal to q naught e power iota omega t, or I is equal to I naught e power iota omega t, because we may convert this q as I or I as q. So this is equation actually in terms of q. So we will use this q is equal to q naught e power iota omega t, and putting this value means the second derivative of Q here, and its first derivative you will use the first derivative as here and Q as it is here, and on putting all these values, and finally we get the final same result as we have discussed in the previous article of forced mechanical oscillator. So, there will be different type of results we can get. As you know, x is equal to minus iota f naught upon omega zm into e raised to power iota omega t minus phi. So, this type of behavior can be obtained by solving this. You will solve this equation yourself and you will get the same type of answer, that is this x is not there, here it is q. So, q is equal to minus iota f naught upon zm into e power iota omega t minus phi. Okay. So, in this way you can find the values of x and velocity and acceleration by using different values. Yes, ma'am. So, there is analogy between the results of mechanical oscillator and electrical oscillator are x is same as q and dx by dt, which is equal to velocity, is same as dq by dt as current. So, same type of results as we have discussed in x and velocity in mechanical oscillator. So, we will discuss here q and current. So, current is the analogy of velocity and charge is the analogy of displacement. So, we can get the same type of answers and same type of graphs. So, you will solve these articles yourself, that is in case of x means q versus omega and velocity means current. You know that velocity is same as current and x is same as charge. So, versus omega. So, you can solve that, find the graph type of this like this, and the velocity, this type of graph is obtained. So, this graph starts from 0 and z0 in case of velocity or current, and in case of displacement it starts from finite value f naught by s, and final value is at 0. So, same type of results, that is x, q or velocity and current are same. So, this is forced electrical oscillator. You can solve these articles and trace these graphs by solving the equation of force oscillator. So, this is second type of force oscillator, that is electrical force oscillator. Now, after that we will find power of the circuit in the next lecture. Thank you very much.